Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here is information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's the problem for today for exam LTAM. This is the last problem from the last exam in fall 2019 course LTAM examination. Problem number 6 from the written answer section. An insurer issues a 20-year deferred annuity contract to a 65-year-old. Level annual premiums will be paid for a maximum of 10 years. On survival to age 85, an annuity of $36,000 per year is paid annually in advance. If the life dies after 10 years, but before first annuity payments, the premiums paid are returned without interest at the end of the year of death. There is no payment on death in the first 10 years. You are given the following premium assumptions. Mortality follows the standard ultimate life table. Initial expenses are $1,000 plus 30% of the premium. Expenses of 5% of the premium are payable with the second and subsequent premiums. Renewal expenses of $100 per year are payable annually in advance throughout the term of the contract starting in the second year. Interest rate is 5%. Premiums are calculated using the equivalence principle. Question A. Show that the premium is $10,260 to the nearest 10. You should calculate premium to the nearest 0.1. The insurer profit tests the policy. You are given the following assumptions for the profit test. Mortality rates are 90% of the mortality rates in the standard ultimate life table. For the first 5 years of the contract, 3% of policyholders who survive to each year end lapse at that time. There are no lapses after the first 5 years. Pre-contract expenses are $7,000. Maintenance expenses start at $70 at the start of the first year and increase at a rate of 2% per year. Premium expenses are 5% of each premium, including the first. The insurer's funds earn 7% interest each year. The hurdle rate is 10%. Reserves at times 0, 1, 11, 12, and 29 and 30 are reserve at time 0 is 500, reserve at time 1 is 10,150, reserve at time 11 is 143,035, reserve at time 12 is 151,210, reserve at time 20 is 155,745, reserve at time 30 is 146,275. Part B. Calculate profit at time t for t equal to 0, 1, 12, and 30. Part C. The insurer calculates the net present value for each policy issued as $8,860. Calculate the net present value at the start of the second year of future cash flows for each policy in force at that time. And here's the solution. Part A, or question A. Let us denote the level annual premium by P. P is calculated using the equivalence principle. Therefore, the expected present value of the premiums is equal to the expected present value of return of premiums plus expected present value of payments, benefit payments of various types, plus expected present value of expenses. And that means that P times 0.95 A double dot 65 colon angle 10 minus 0.25, that's the expected present value of premiums after expenses, is equal to 10P times 10E65 times A 75 colon angle 10 1, which just the return of premiums if the person dies in the period after 10 years but before 20 years. Plus 36,000 times 20E65 times A+.85, that's the present value of life annuity, which is the other form of the benefit, plus 900 plus 100 A+.65, that's the other expenses that are not a fraction of the premium. And from this, P is equal to 36,000 times 20E65 times A+.85 plus 900 plus 100 A+.65 over 0.95 A+.65 colon angle 10 minus 0.25 minus 10 times 10E65 times A75 colon angle 10 1, which is equal to A75 colon angle 10 minus 10E75. And the reason why I write it this way is because these two quantities, A75 colon angle 10 and 10E75, are in the standard ultimate life table, so we can look them up. And now everything that is in here in this formula for P is in the table, so we just look up all those numbers, plug them in, and get 10,259.39. Part B. Question B. Profit times 0 is minus the expense minus the reserve at time 0. That's negative 7,000 minus 500, so these are the large setup expenses. And that's negative 7,500. And then for t greater than or equal to 0, we have the recursive relationship. That profit at time t is the reserve at time t minus 1, plus any cash flows that come in or come out if it's the payout of some type, minus expenses plus interest, minus expected death benefit, minus expected value of the next reserve. Which is really the recursive reserve formula, because the profit is really what is left after you do the standard recursive reserve formula. If you do the standard recursive reserve formula and you get the reserve in the next year, if there's any money left over, that's the profit. That's really the definition effectively. Well, the cash flow is the premium for t equal to 0, 1, and so up to 9 for the first 10 years. No cash flows for the next 10 years, and then negative 36,000 for t equal to 20, and so on. Okay, therefore the profit at time 1 is reserve at time 0 plus premium minus the expenses, which is a fraction of the premium, plus 70, 0.5p plus 70 times 1 plus the interest rate, minus 0 minus 1 minus 1.03 times 1 minus 0.97 Q65 for survival times the reserve at time 1. And we just plug in all these numbers, and we get 1095.68. Profit at time 12 is reserve at time 11 minus the expenses, which now become 70 times 1.02 to the 12 because they increase at 2% a year, times accumulated with interest, which is the interest rate earned by the company, so 7%, minus 0.95 Q76 times 10 times 259.39, minus 1 minus 0 times 1 minus 0.9 Q76 times reserve at time 12. And again, we plug in all the numbers, and we get approximately 2,648.64. For profit at time 30, well, now we're paying out the 36,000, so we need to subtract that. So reserve at time 29 minus 36,000 minus 70 times 1.02 to the 29th, accumulated with 7% interest, minus 0 minus 1 minus 0 times 1 minus 0.9 Q94 from the standard ultimate life table times reserve at time 30. That's all of this is now given. We plug them in, and we get 2,262.995. And question C. Let us denote by NPV1 the expected present value at the start of year 2, which is time 1, of future profits per policy in force. This is the quantity we need to find, and that is equal to a profit for the second policy year times 1.1 to the negative 1. Remember, the profit is calculated for all the policies in force at the beginning of the year, so we don't need to make an adjustment for any probability here. Plus, given survival to the next policy year, profit for the third policy year times 1.1 to the negative 2, and of course note that we're discounting at the hurdle rate at 10%, because that's the rate that is used for calculation of present value of profits. And again, survival to next year and the profit and so on, discounted again. The quantity given in the problem, the net present value, is 8,860. That's equal to profit at time 0 times 0px00 plus profit at time 0 plus subject to survival profit in year 1, but the survival is to the beginning of the first year profit, first year of the policy, so really to time 0. So this is certainty. So this 0px00 is 1. Times profit for the first policy year times 1.1 to the negative 1. And then profit to the second year, subject to survival to the beginning of the second policy year, discounted over 2 years, and so on. We continue. And this can be rewritten as profit at time 0 plus first year profit discounted at 1.1% plus 1px00 times 1.1 to the negative 1 times net present value at time 1. If you take a look at it, it's exactly that. Therefore, we have this, that 8860 is negative 7,500. That's the setup, all the expenses at time 0 setup and everything. Plus 1095.60 over 1.1, plus 1 minus 0.03 times 1 minus 0.9 times Q65, which we get from standard ultimate life table, times net present value at time 1, the whole thing divided by 1.1. And that's an equation in which net present value at time 1 is the only unknown, so we solve for the net present value at time 1, and this is equal to 8860 plus 7500 times 1.1 minus 1095.68 divided by 0.97 times 1 minus 0.9 times 0.005915, and it's approximately 17,516.26. And that's the end of this problem. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test. Let me note that with this problem, I have posted every single problem from the last exam LTAM. In fact, every single problem from every exam LTAM offered is in this video channel, so you can watch all of them. And of course, I will put more problems. And please subscribe, and please consider making a donation to the actuarial program at Illinois State University. And of course, you should come study with us. It's a great place to study. We're right in the middle of the state of Illinois. The winters are extremely cold here, with winds, snow. We're surrounded by cornfields. There's nothing here. Really no social life, nothing to do. The only thing you can do here is study. So, parents of prospective students especially, you should remember this is such a great place. Your kids will have nothing to do but study if you come study with us. Absolutely wonderful. Well, all the best, and I hope you all stay healthy during this troubled time with coronavirus. I wish you all the best of health, and I'll be posting more problems soon. Well, tomorrow, soon. Have a problem a day. It's a good diet.